Hello, this is Matt Markin, an academic advisor here at Cal State San Bernardino, and welcome back to the CSUSB Advising Podcast for our 69th episode. On today's episode, we have Dr. Doug Smith, professor and department chair of chemistry, so that way we can learn more about the chem majors. Dr. Smith, welcome.
Thank you. Yes. Good to meet you.
Yeah, good to meet you too. Can you tell us a little bit about yourself and maybe your background in higher ed and being at CSUSB?
Absolutely. I initially did my undergraduate studies in Ohio, a small little liberal arts college. That was back in 84 to 88. The school is Wittenberg University. I'm sure you've never heard of it, not expect it. I graduated with a BA in chemistry with an American Chemical Society certification. We actually have a professional organization. It's the American Chemical Society. They set up a lot of the guidelines for chemistry majors, and there's usually a few extra requirements for that. We call it the ACS, American Chemical Society certification. That'll be relevant in a bit. I did my graduate studies at Purdue University in Indiana from 88 to 94. My area was a degree in chemistry with a specialization in organic chemistry. I did postdoctoral studies, research, teaching also from 93 to 95. That was at Eastern Illinois University. Basically, for those of you who may not be familiar with the postdoctoral studies, you can think of it as something like an internship or a residency for new physicians. Before they actually start their own careers, they have to do a little bit of an apprenticeship, might be a better way of putting it. I then started here in 1995, and this is now my 29th year at Cal State.
Oh, nice. So going on the 30th year.
Yeah.
And so for undergraduate students, you have the BA and the BS in chemistry. Like, how would you describe the chemistry major?
So in the Department of Chemistry here, we have two majors. We have the BA in chemistry and the BS in chemistry. Both of these programs have a regular chemistry and a biochemistry option. The BA has just the regular program. The BS offers ACS certification in both the chemistry and the biochemistry options. We have a minor in chemistry. We have a joint program, master's degree that we share with geology. It's environmental sciences. And we also are having soon a material science program, master's degree, that we're going to share jointly with physics. That's scheduled to start in fall 2024. About chemistry itself, it's part theory, part applied. There's obviously some very conceptual parts to the theory. There's also some mathematical aspects to the theory. You can't really get away from math when you're in the sciences. We also basically have the laboratory portion, which is very much more applied. So you can think of the theory as setting up the knowledge base for working in the applied sections in the laboratory.
All right. And students might be interested to know too, like, just generally speaking, like, what are things that maybe a student would be learning in their classes?
That's a great question. Thank you. So we actually start out with the general chemistry sequence, and that's very light treatment or a lot of introductory presentations for the chemistry topics. After that, the classes generally become far more specialized. Generally speaking, after we have general chemistry, we have analytical chemistry. And analytical chemistry is one of those areas that kind of tries to answer two questions. How much? How much of something maybe is floating around in the environment? Like what percentage of pesticides are we seeing? What are the trace levels? Are we possibly exceeding, for example, federal standards? Locally, we actually had a fireworks factory, and one of the things that they found is there's a contaminant known as perchlorate, for example. And one of the things that some of our people work on, and as part of the research, is studying how much perchlorate is actually in the sample, and is it at actionable levels, for example. We also, sit there and say, okay, we have this unknown sample. What is in this unknown sample? So that's kind of the what is it portion of analytical chemistry. And that ties in directly into the environmental sciences courses that we teach. We have atmospheric chemistry, for example. We have an environmental chemistry class, and both of those relate back to the whole how much and what is it. We also have organic chemistry as a subdivision, and organic chemistry is highly specialized because it focuses mainly on one element and its relationship to other elements. And the element in question is carbon, which is basically the foundation for life. Which actually, incidentally, leads into the next topic, which is biochemistry. And biochemistry is kind of the interplay between organic chemistry and biological systems. And actually, there would be pharmacology issues related to that. There's a whole subdiscipline of bioorganic chemistry. So it's actually really, since biochemistry is a very expanding topic right now, it's a very great field of study. We also have inorganic chemistry. Inorganic chemistry is, I like to refer to it as being studying all the other elements besides carbon, hence the inorganic chemistry. One of the common areas that they actually investigate are what are called the transition metals. If you're familiar with the periodic table at all, it's kind of that middle section right there where you have the spiky one end and the spiky other end. So it's kind of that section in the middle where you have a lot of the metals. We also have material science classes. Material science is actually a very growing area of study. It's very interesting. There's lots of things going on there. And that actually ties into the master's program I had mentioned earlier. An example of what you might look at with the material science is polymers, for example. Polymers are everywhere. If you're writing with a pen, it's probably produced by polymers. Fabrics for clothing, polymers. So it's basically, for example, polymers are one of those things that are pervasive through our society and unfortunately also our environment. They're finding microplastics, for example, in our oceans. They've recently discovered microplastics in our atmosphere. And those microplastics are actually polymers. We also have physical chemistry as one of our other areas. And physical chemistry, to summarize it, it's a lot more mathematical than our other areas of chemistry. And you can liken this to basically studying things like how fast reactions go, how does the energy change during a reaction. It also looks at the structure of molecules and atoms at a molecular level. It's very calculus based. It's highly conceptualized at that level.
All right. And, going into one of the other questions that we get a lot, I'm sure you get it too, is the career question.
Yeah.
So if I had this major, what are career options I can go into? So can you talk more towards like maybe what some of your students have gone into after graduation?
Absolutely. The chemistry major is pretty versatile. One of the things we do tend to do is we send a lot of our students, graduates, out to graduate studies. And graduate studies in chemistry will actually expand your marketability when you're out in the job market. A lot of times what they want to see, employers want to see, say, for example, a year or two of experience. And graduate studies would give you that 1 or 2 years of experience. We also place people into positions such as research and development. Common area where you might see that would be, for example, in the pharmaceutical industries. They're always trying to develop new medications. They're trying to develop processes for producing these medications. And they're actually trying to design new medications. And all of that kind of goes under the heading of research and development. And not just for the pharmaceutical industry, that just happens to be a convenient way of presenting that information. Manufacturing, also very common. There are chemical supply companies that supply materials in bulk. So we have chemists that are graduates who are out there in the field actually producing bulk supplies of chemicals. Government positions are very common. We have placed graduates into the Food and Drug Administration, the FDA. More locally, the South Coast Air Quality Management District. Hazmat is another place where county offices deal with hazardous materials. Chemists are very well suited for those types of positions because they have the basic knowledge base to understand the concerns. We've also placed students in the crime labs locally, the county crime labs, excuse me. And we've also placed a few students in the Drug Enforcement Agency. We actually have 2 of our graduates right now working at the DEA office down towards San Diego. Health professions are also quite common areas where our graduates go. You do not have to be a biology major to be pre-health professional. We have placed students in the medical schools, into pharmacy schools. We tend to see fewer of our majors going into the dental schools. A lot of times you'll see more biology majors doing that. Teaching, high school, very common. We have placed quite a few students into local high schools teaching. Sales representatives, there's another place where we actually have placed some students. They actually work on sales, selling bulk materials, that sort of thing. Also, service representatives. Some of our students have actually gone on, done some additional trainings with companies, and these are the people they sent out in the field to help departments and industry to fix the problems that are going on with their chemical instrumentation that I mentioned earlier.
Right. So yeah, a lot of different opportunities and options for students. And let's say students listening to this and they're saying, this sounds interesting, but maybe they're on the fence of declaring or not sure if they should do the BA or the BS or which option within either of those. Any advice you have for that student?
I will say that we do get quite a few converts. And by that, I mean, we start out with people in one major coming over to our other. We actually tend to pick up, for example, a few biology majors that get into chemistry and say, hey, this isn't so bad. We actually kind of like that. So basically, one of the things I'd recommend is meet with an advisor in the department. Find out more, like the information we're sharing right now on this podcast. Also, not only meeting with an advisor, take an introductory class. There are some GE classes that you can take. I know of at least one of our former chemistry majors that started out in the lowest level GE class, said, I actually like this, I want to learn more, took another class, continued to enjoy it, and then she eventually received her bachelor's degree in chemistry. So by all means, I would recommend taking some introductory classes just to see if it's for you, see if you enjoy the material.
Yeah, sounds good. Now, are there any misconceptions that you think someone might have when they hear chemistry, the word chemistry?
There is, I think, a tendency to be almost what I would call chemophobic, if you will, that some people are a little concerned about handling the chemicals. We train heavily on safety. We're very big on safety here. We're all about handling things safely, working safely, making sure our students are not injuring themselves or being adversely exposed to anything. A lot of people think chemistry is only about mathematics. I will be honest, I wasn't the biggest mathematician, if you will. So that's why I kind of gravitated, for example, to organic chemistry. But it's not all about math. There are other areas that don't necessarily rely as heavily on mathematics. Biochemistry would be another option for that. I would say it is a challenging major, but it's actually interesting. It has a lot of job opportunities. It's not limited. A lot of people think maybe careers are limited as either being a high school teacher or working out in industry. No, we have a lot of other options. So I think that's another common misconception.
Yeah. And lastly, are there any resources that your department might offer students, whether it's clubs, tutoring, scholarships, anything like that?
Great question. Thank you. One of the things I can say, our biggest asset are our staff and faculty. They are great. We are always willing to work with our students. That is our primary job. That is our number one responsibility. And I think I can say we in the department take that responsibility very seriously. Clubs, we did at one point have a chemistry club, but during the required distance learning during COVID, some of that fell apart. We had a very active club prior to that. We are actually working to reestablish that club. That club was a great source out to the public. We did a lot of basically outreach activities in the community. We've engaged in tutoring, not only high school, but also here on campus for helping students get through their courses. We actually do have an in-house scholarship. It's called the Petrucci Scholarship. Petrucci was one of our former department members. He had his own textbook. It's a great textbook. And when he retired, after he retired, he set up an endowment for basically scholarships. And there are a lot of scholarships on campus, not just in the department here, but there are other scholarships on campus that can be utilized by our students. Another thing is, and this is kind of big, is you got hands-on opportunities. And I think that's one of our biggest selling points. Unlike the UCs, you're not going to, or at the UCs, I should say, you're probably not going to have a lot of direct contact with your professors. At Cal State, we're about teaching primarily, so you're going to have a lot of one-on-one face time with your faculty members. And that kind of leads back to faculty being a valuable resource. But not only that, because we are smaller, we actually provide more hands-on opportunities in laboratories. For example, our students get access to chemical instrumentation that they would not normally get access to at the UCs. So you actually get more breadth in terms of what you can do. Also, research opportunities. All of us are engaging in professional development activities, and we recruit heavily from our undergraduate students. So again, this is one of those situations where this is an opportunity here at Cal State, not just in our department, but other departments that you might not be able to get access to at some of the UC systems and the bigger schools.
Nice. So yeah, definitely a lot of opportunities, a lot of great information that you've given here today for students. Dr. Doug Smith, thank you so much for being on the podcast today.
Thank you very much for having me. I sincerely appreciate it. Thank you for this opportunity.